Okay, sorry about that, you guys. I got a spam phone call, and I didn't realize that when you get a phone call, it stops your recording. So anyway, so just picking up right where we left off. Okay, so we have the probability of queen or a club, and what we were saying is that these are not mutually exclusive, okay, right? There is the queen of clubs. So what that means is when we go to do this problem, it's going to be in addition, the probability of queen plus the probability of club, but then we're going to have to subtract away the probability of the queen of clubs. Okay, so thinking about the deck, how many queens are there in the deck? Right? Altogether there are 4. So 4 out of the total, remember we're back to the deck, so this is 52. How many clubs are there? In total, how many clubs are there? There are 13 out of the total 52. But then one of those cards is the queen of clubs, right? Now the queen of clubs, did it get counted here? Mm-hmm. Did it get counted in here? Okay. So how many times did it get counted? Twice. So there's your overlap. So we're going to subtract away the extra counting. Now there's only one queen of clubs, so we subtract away just one. Okay. And if we stick that whole thing in our calculator, we end up with the 0.308. Again, so the 30.8%. Okay. Let's do one more, just so that finish it off here nice and strong. Let's see, we're going to draw a card again. And this time I want the probability that it is a face card or a red card. Okay, so a face or a red card. So again, we think about what we know. So are there any face cards that are also red? And there are, aren't there? So this is definitely not mutually exclusive. So that means that we're going to have to go the probability of face plus the probability of red. But then we're going to subtract away the probability of the red face cards. Red faces. That doesn't sound well. Okay. So again, we said how many face cards are there in total? There are 12. How many red cards are there in total? Okay. There are 26, right? Half the deck. Okay. So how many face cards are red then? If there are 12 face cards in total, then half of them are red, aren't they? So there are 6 red face cards. Did those 6 red face cards get counted here and here? So we're going to subtract away the 6 that got double counted. And here we will end up with, I got 0.615. Okay. Get the idea? Okay, so there's a little bit of extra thinking you have to do when things aren't mutually exclusive, but it doesn't mean we can't do the problem. It just means we have to think a little more. Now, here's the dealio. I know that none of the calculations that we've done on the board so far have been like overly taxing or anything, but just because I'm doing it here and you're like, oh, that's fine, I wouldn't trust me, okay? I'm human just like you. It's very possible that I hit the wrong key or whatever. Make sure that you're doing these calculations yourself as well. Okay, so that you, first off, so that you get into the habit, but also in case you find a mistake. And if you find a mistake, let me know because I want to fix that for everybody. But so I don't want you just to get into the habit of just following through the lectures and not actually doing any calculations. Make sure that you're doing your calculations as well, even if you have to push pause for a second, okay? All right, so that's the addition rule, okay? So we are now able to do problems that say or in them. Next will come the multiplication rule, but that's next time. Okay? All Have a great day.